Hello guys, you're welcome back to my channel Fun with Physics. I hope you are having a swell day. How are you doing today? I hope you're enjoying your day, you're having fun. In today's lesson we're going to look at the application of pressure in liquid or liquid pressure. You can otherwise call it using pressure in liquids. Okay? Now as a starter, can you explain why water from an overhead tank in buildings flow faster downstairs than upstairs? Now, if you have your tap downstairs, you observe that it's much more faster compared to your neighbor upstairs. Why is that so? Okay, I want you guys to think about this. Try to apply the knowledge, what you learned from the previous lesson to answer this. Okay, now explain why a bubble of gas increases in size as it moves from the bottom to the surface of a pond. As you can see there, the bubble is increasing. Remember we talked about pressure increasing with depth, right? So at this depth here, the pressure is more. You can guess that the pressure acting on the bubble is from all directions, isn't it? And acting from all sides, trying to compress it, right? But the more the bubble moves upward, the pressure acting around it will decrease, okay, until it gets to the top. At the top, where the pressure is very low, not actually very low, but low compared to the bottom, the bubble is bigger because we don't have much pressure acting from all sides like what we have below. Okay, so basically it's because pressure increases with depth. All right, so in other words, from what we see here, we can also say that if pressure is decreasing, the volume of air in the bubble will be increasing, or the volume of the bubble rather will be increasing. Transmitting pressure in a fluid. Now we discussed this last week. When a force is applied to a confined fluid, the change in pressure is transmitted equally in all parts of the fluid. Okay, the word fluid means liquid or gas. So when you pressurize is when you apply a force on this. For what we have in the second picture here, we can see that the pressure inside is increasing, right? Because you are increasing the force, and the pressure is transmitted in all directions in it. Now, using pressure in liquids, liquid cannot be compressed. We know that pressure applied at one part of a liquid will be transmitted throughout the liquid without change. If you have this is a liquid, and this is a syringe, a piston. Okay, it's a piston. It can move up and down. Now, when you apply force on this piston, pressure transmits in this liquid throughout to this point, and then exerts a force. Okay, the pressure here exerts a force on this one, making it to go up. So the reverse is the case, vice versa. The same thing applies to the right hand side here, what you have. So if a syringe and a tubings are filled with water, when the plunger of one of the syringes is pulled in, the plunger of the other syringe pushes out. The pressure from the first syringe is transmitted through the liquid in the tube to the second syringe. Okay, remember this liquid is not you cannot compress it. So because you cannot compress it, I told you earlier that once a pressure is generated in this liquid here, it transmits. It's transmitted in all directions. Okay, it's transmitted throughout the liquid to this point. Okay, so the pressure exerted here will force this, creates a force that will make this to move up. This simple design This simple design, what we learned, what we saw in the previous slide, is used for all hydraulic systems. Now the question is, what are hydraulic systems? They are actually systems that use one form of liquid or the other, okay, to transmit pressure. Now we can actually apply that principle we learned earlier to every form of hydraulic system. Now in a very short while you're going to see different types of hydraulic systems. Okay, now in this system, this is a piston in a smaller cylinder and then another one in a bigger cylinder. Then inside we have liquid. When you apply a force of, let's say, 4 Newton, which is the input force on this side, okay, it's going to cause pressure to be exerted in the liquid, which will be transmitted to this point and then give out an output force of 12 Newton. Now what did you notice about the force? It is multiplied, right? It's multiplied, like it's multiplied by 3. It's increasing 3 times, or it increases 3 times, isn't it? Okay, so another thing you noticed here, you can notice here, is that this cylinder here is much more bigger than this one, right? And the area here is much more bigger than the area here. Okay, small force here can cause a bigger output force on this other end. Okay, in a short while you're going to see why it is so. Hydraulics. Now hydraulic system uses the principle that pressure is transmitted throughout a liquid. Okay, now this is an example of a hydraulic system. This is like a lift, a car jack using liquid. This is where you apply your effort, you know, to push it down, and then the load here, this piston here is going to move up with the load, moving the load up. Okay, so hydraulic systems uses the principle that pressure is transmitted throughout the liquid. They are used to transfer movement from one part of a machine to another without linking the parts mechanically. So there are lots of hydraulic systems or hydraulic machines we have available. You don't need to connect parts together. All you need to do is to link one part with the other using liquid. Okay, now pressure that is transmitted in the liquid will cause this other part to move. A little effort here will cause a big load here to be lifted up. That's how hydraulic systems work, and we have a lot of things, a lot of machines that use hydraulic system. All hydraulic systems uses 2 pistons linked via a pipe carrying a special oil called a hydraulic fluid. Can you guys list some of the hydraulic systems you know? Some of the systems that uses fluid to transmit force, okay, rather to transmit pressure, which will cause force to be exerted on a particular point. You have an idea? Okay, don't worry, we are going to see some examples later. Hydraulic systems uses 2 properties of a liquid. One of the properties, liquid is incompressible or cannot be compressed. They use these 2 properties. All hydraulic systems, all hydraulic machines. By hydraulic system, I mean hydraulic machine, anything that uses liquid to operate. Okay? They use 2 properties of a liquid in their operation. One of it is that liquid cannot be compressed. Another one is liquid pass on or transfer any pressure applied to them equally in all directions, like you can see on this diagram. Okay? So you can compress liquid, compress them down, and when you apply a pressure on this side or a force here which will result in pressure on the liquid, the pressure will be transmitted equally in all sides, in all directions, throughout the liquid, throughout the fluid, throughout the system. That means the pressure here, if it's 20 pascal, the pressure here is going to be 20 pascal, on this side is going to be 20 pascal, on the top here is going to be 20 pascal, on this side here is going to be 20 pascal. The pressure will be equally, will be transmitted without loss in all directions. The force applied in one piston on piston 1 produces a pressure which transmits through the liquid to produce a bigger force to move piston 2 upward. Okay, so you apply a pressure here, a force here, it causes a pressure in the liquid, and the pressure transmits. It's not the liquid that is moving, but the pressure that is transmitting. The pressure transmits in all directions, transmits throughout this liquid, okay, acting in all directions to this point. So on getting to this point, the pressure exerted on this point causes this bigger piston to move up, okay, that is exerts more force on this side. Okay, examples of hydraulic systems. Here we talked about hydraulic systems, and now these are some of the examples. Number one is the usual hydraulic car jack you see in a mechanic workshop. Okay, there's this car jack. If you go to a mechanic workshop, you see a car jack. If you have a car, and if you're lucky, you have the hydraulic one. Okay, there are two types anyway, but you have the hydraulic one. If you have the hydraulic one, that is the one I'm talking about, the one that uses liquid. Now we also have this hydraulic press that can be used to press down things, to compress things, like what we have in the picture. We also have hydraulic car brake. Okay, to amaze you to know that our braking systems are all hydraulic, except in few cases like bicycle and all of that. But in car, the braking system, they are hydraulically operated. Okay, like what we have here. And then hydraulic car lift. Okay, these are some of the examples of hydraulic systems, right? Okay, now how do they work? How do they operate? How do they work? By changing the size of the pistons of a hydraulic machine, the force can be multiplied. Okay, now it's a simple design. Look at this. When you change the size of the piston, one of the piston, the force here applied here, whatever force you apply here can be multiplied here. Okay, now notice that the area here is small. Now the moment you apply a force here on this liquid, there will be pressure that will be produced, right, exerted. Now the pressure here will be transmitted to this point, which will exert a bigger force on this piston here to move it up. So if a force applied in a small area produces a pressure of, let's say, 400 pascal, and the pressure transmits and encounters a large area, like what we have, transmits, the pressure moves and encounters a large area, the force produced on that area will be bigger because of the bigger area. Okay, what I'm trying to say in essence is this: when you increase the area that you're applying a steady pressure, the force will increase. Okay, that is, force increases as area increases at constant pressure. Remember, the pressure in this system is the same. Okay, but when you increase the area where the pressure is acting on, the force that it will be exerted on that area will increase. Okay, so that means force and area are directly proportional at constant pressure. Are we good? So force on the large piston is multiplied, like what we have here. Force on this piston is multiplied. Now let's look at the case here and see how it actually works. Now this is a guy that exerts 10 Newton force on this piston. The whole system here is a hydraulic car lift. Okay, he just 10 Newton and he stands on this piston. Of course we know that there's no way guy can be 10 Newton, but we're just assuming. Okay, he stands on this lift here, exerting 10 Newton force downward. Okay, now you can see that the pressure here indicated by the red, this is transmitted throughout to lift this other side. And the area of this piston here is 20 centimeter square. Now we have some few questions here. I wanted to find out the force that will be exerted here. Now what is the pressure of the left piston? The pressure exerted here. Remember that we can always get the pressure exerted here by dividing, right? Force over area. You can always say force over area, like what we have on the diagram. So the guy is exerting a 0.5 Newton per centimeter square pressure on this side of the fluid. Okay, now what is the pressure on the right piston, on the side of the piston, on this side? Can you guess, or can you tell me? Yeah, like we said earlier, that the pressure is going to be transmitted equally without loss throughout the liquid, isn't it? So the pressure on the right side is going to be the same thing. The pressure on this side is also going to be the same thing. Pressure produced here will be the same thing, will be the one transmitted here. So the pressure on the right will be 0.5 Newton per centimeter square, like it was before. Okay, now question 3, what is the total force of the right piston? What force will now be exerted on this piston, on this side of this piston? Now remember, from our triangle formula, if you want to find the force, you have to multiply pressure times area, right? So we can get the force by saying pressure times area, and then 0.5 times 400, which gives us 200 Newton. Now remember our triangle formula. You want to find force, you say pressure times area. You want to find pressure, you say force over area. Don't forget this, it's very useful. Okay, now notice how I calculated, I solved the problem in hydraulic system. Very simple. So get the pressure on one side, it's the same pressure that is acting on the other side, use it to get the force that is exerted on the other side, or on the large piston, right? Okay, now we were able to get 200 Newton, isn't it? We see that the hydraulic car lift, or a car jack, they work on the same principle. It's a force multiplier, that it multiplies the force applied on one end. Okay, the 10 Newton force was multiplied 20 times, that is 10 times 20, which is 200 Newton, to lift the car. Okay, however, we need to know that the large piston will only lift car through a small distance. So in a real case where we use this, you or the mechanics constantly need to pump oil to take it further. You want to take the car much more further, you need to pump more oil into the system. Okay, we need to take this as a note. Now pressure in hydraulic system, we can calculate pressure in a hydraulic system from what we have on this what you have on the screen there. So pressure on a small piston, if you have this, like what you have, this is the simplest system you can think of. The simplest hydraulic system is made up of 2 strings, one big and one small string, right, connected with the rubber tubing. Okay, so pressure at small piston on this side will be force over area, or F1 over A1, whatever is the force here, call it F1. over A1. Okay. Pressure at the large piston here will also be F2 over A2, whatever is the force here over the area there, this area, okay, the area of the piston. All right. Now, since the pressure transmitted is equal, did not change, without change, we can see that the pressure on this side is equal to the pressure on this side, right? Pressure on this side is equal to the pressure on this side. So we can equate the two formulas. F1 over A1 equals to F2 over A2, like what we have, okay? Now, this formula can be applied to solve the previous problem we solved earlier, the problem we solved earlier, okay, for gifted students. You want to solve this problem, you don't want to take it step by step like this, you can just apply this formula. F1 for the first force on one side over the area equals to F2, the second force that you're looking for, over A2, the area that you know. All right. If you like, you can put it this way. It's up to you. Force A, area A. Force B, area B. It's up to you. Okay. Now we have another hydraulic system we want to look at critically and understand, which is the hydraulic brake or braking system that is used in cars. Okay. Now, what you have on the screen here is somebody that is about to press the brake. This is what you see, right? This is what you get to see. But this is what you don't see. This is the internal system, what is actually happening inside the car that you don't get to see. In the car, we have the braking system, what that you see. They are all connected with links to a piston inside a cylinder, okay? The cylinder contains brake fluid. Brake fluids are actually special fluids that cannot compress easily. They cannot compress, you can't compress them. Okay? On this side, this cylinder here is actually called a master cylinder because it holds the master piston, the piston that exerts the pressure on this side. Okay. Now, once you press the brake, pressure is exerted on the liquid and it's transmitted throughout to the brake calipers to this side. Okay. Now, the brake calipers holds the slave cylinder. The slave cylinder is where you have the slave pistons that can move apart. Okay. Now, the brake pistons are attached to the disc pad that can grip on the wheel and stop it from moving. I hope it's clear. Now, pistons in the slave cylinders are always larger to produce bigger force. Okay. So that means here, the pistons here will be bigger than the piston on this side, so that the force here can be multiplied. Okay. So if you're driving a car and you apply a small force, the force can be it's actually multiplied by the pistons, the bigger pistons on the slave cylinder on this side. Okay, magnified, multiplied to stop the wheel from rotating. Okay. So without this system, it will be difficult for you to stop cars like truck. Even your car, normal car, it will be difficult for you to stop it. You need to apply extra force to be able to stop a moving car. But this system is a very good design that we use today. How many stages can you remember from what we discussed earlier about the hydraulic brakes? Let's see, how many stages can you remember? Number 1, number 2, remember this, the brake pad, right? Number 3, what do you call this? This whole arrangement here, what do you call it? The master cylinder, isn't it? How about this arrangement here, number 4, what do you call it? These are connections, right? The pipes connect. And then this number 5, what do you call it? This is where we have a bigger piston, right? Bigger piston. It's the slave cylinder, isn't it? That holds the bigger piston. so that more force will be exerted here. On this side, you have the parts, isn't it? The brake parts that can grip this, right? And they are connected to what we call the brake calipers. Okay, now this one is slightly different because it has a mechanism that controls the part here, or the disc part. And then this is the wheel, isn't it? Now what will happen when the pipe in the hydraulic brake of section 4, this pipe here, bursts? When the pipe bursts and air flow in, what will happen? What will happen as this guy is exerting the brake? What will happen? Okay, I want you guys to think about this critically and then tell me what will happen on the comment section of Google Classroom. Okay, using pressure in liquid. This is another case where we use pressure in liquid. The moving arm on a mechanical digger. If you've seen a mechanical digger, all these arms, they are hydraulically operated. Okay, a small force here exerted at the driver section can actually cause all this digger to dig or to exert bigger force, okay, on the digger. Right now, for the closure, I want you guys to list other examples of hydraulic machine around you. There are lots of hydraulic systems or machines around you. Things that work with fluid, that work basically by transmitting pressure through a fluid. Okay, you apply a little force on one side, the pressure is transmitted in the fluid to exert a bigger force on the other side. There are lots of cases. Okay, guys, comment on Google Classroom. Give me one example. Okay, I want to see you give me one example. Think about it. There are lots of examples around us, so think about it and give me one example. I've given you some examples. All right, have a nice day.